Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing bedtime astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky.
Imagine a gold rush, but instead of pickaxes, mules, and dusty riverbeds in California, you have autonomous spacecraft, ion thrusters, and high-powered lasers.
Right.
And instead of a stream, the gold is moving at roughly 20,000 miles per hour in the absolute vacuum of space.
And here is the kicker to that whole scenario. There is no sheriff. There is no mayor. There isn't even a map.
Exactly. We are taking a deep dive today into something that sounds like science fiction.
Oh.
But it has quietly, almost deceptively, become a business reality. As of this very month, February 2026, we are talking about asteroid mining.
Yeah, and we aren't just looking at the cool rockets or the stock prices. We're looking at a pretty fascinating stack of research, specifically a new paper out this month in Acta Astronautica by Dr. Anna Marie Brennan from the University of Waikato in New Zealand.
And this paper is essentially a fire alarm. It's a wake-up call saying, hey, the technology's ready, the companies are launching, the hardware's in the void, but the rule book, we lost the rule book 40 years ago.
Which is exactly the core conflict we are unpacking for you today. It's this massive race between engineering, which is moving at warp speed, and international diplomacy, which is moving at the speed of the UN.
Which is to say, glacial.
Very glacial.
Right. So here is our mission for this deep dive. We are going to walk you through the actual hardware operating right now. Not the plans, not the CGI renderings, but the actual metal in space. Then we're going to pivot to the why. Why are people freaking out about the legal side?
And finally, we're going to look at the proposed solutions to stop space from becoming a literal Wild West.
And sticking with us is totally worth it because Dr. Brennan introduces a concept called irreparable breakage. It sounds like a warranty clause you'd find on a toaster, but it's actually this profound philosophical argument about whether humans have the right to destroy a celestial body. It flips the whole script on environmentalism.
I love that concept. We will definitely get there. But first, let's ground this for the listener. Because I think a lot of people hear asteroid mining and they think of that movie Armageddon, or they think of distant futures like The Expanse.
Yeah.
But the source material makes it incredibly clear that this is happening right now.
It really is. As of February 2026, we have moved past the PowerPoint phase. We are in the hardware phase. The research points to two specific commercial players that are defining this landscape right now, Astroforge and Karman+R.
Let's start with Astroforge, because this isn't a government agency, this isn't some multinational defense contractor, this is a startup.
So what are they actually doing up there right now?
So Astroforge is really interesting because they are laser-focused, pun intended, on refining platinum group metals. Their current mission, which is highlighted heavily in the research, is called Vestry. And the operational objective here is huge. They are attempting a landing on a metallic asteroid.
Let's pause on that word, a landing. Because historically, when NASA goes to an asteroid, like the OSIRIS-REx mission to Bennu a few years back, it's usually a touch-and-go maneuver. They high-five the asteroid, grab some dust, and leave.
Exactly. A touch-and-go is brief. Vestry is designed to land and stay. It implies permanence. And technically, physically, that is a nightmare.
Because of the gravity.
Right, you have to understand the environment. You are trying to land on a rotating rock with almost zero gravity. If you push a drill down into the surface, Newton's third law kicks in, and the physics of it just pushes your spacecraft up and away.
It's like trying to drill a hole in a wall while you're floating in the middle of a swimming pool.
That is a perfect analogy. You need anchoring, you need active stabilization, you need harpoons or gripping mechanisms, and Astroforge is attempting this on a shoestring budget compared to NASA.
And then you have the other player, Karman+B. Their profile is slightly different, but equally ambitious, right?
Yeah, Karman+ is focused on the recovery of a multi-kilogram sample. Now, put that in perspective. NASA's OSIRIS-REx brought back about 120 grams. That was considered a massive historic success.
Right.
Karman+ wants kilograms. Their mission is essentially a proof of concept for zero-gravity excavation. They aren't just scraping the surface, they want to dig. They want to prove that industrial extraction processes can actually work in a microgravity environment.
This is where the economic context from the research gets a little scary to me. The paper makes a really sharp point about budgets. When NASA or the ESA does this, they have billions of dollars. They have teams of thousands checking every single line of code. They have redundancy on top of redundancy.
If a valve fails on a NASA probe, there are usually 2 backup valves.
Exactly. But these startups, they are operating on what the industry calls shoestring budgets.
Which, in aerospace terms is still millions of dollars, but compared to a state agency, it's nothing. And that matters for you, the listener, because of the risk calculus.
How so?
When you are a startup burning venture capital cash, you have a runway. You have a finite amount of time to show results before the money runs out and the lights go off. That creates immense systemic pressure to cut corners. Maybe you skip that 3rd backup valve. Maybe you shorten the simulation testing period by a month to make a launch window.
So you have high-speed projectiles, explosives, heavy drills, all operated by companies that are basically racing against bankruptcy.
That is the cocktail. And that brings us directly to Dr. Brennan's research. She argues that because these are private companies with profit motives, not scientific agencies with prestige and safety motives, the probability of something going wrong, reckless behavior, accidents, corner cutting is just vastly higher.
Okay, so let's say something goes wrong, or honestly, even if it goes perfectly right. This leads us to the environmental framework, which I found to be the most brain-breaking part of the reading.
It is deeply counterintuitive, forces you to completely rethink what nature actually is.
Completely. Because usually when we talk about environmental protection, we are talking about biology. We are talking about saving the whales, or protecting the rainforest from logging, or keeping mercury out of the water table so kids don't get sick.
Biological receptors.
Yeah.
Things that can feel pain, get sick, or die.
Right. But an asteroid is a dead rock in a vacuum. There are no whales. There is no water table. There isn't even air. So the skeptical listener might be asking, who cares? Why do we need environmental regulations for a lump of nickel floating in the void?
That's the standard counter-argument. You can't pollute a dead rock. If I smash a rock in my backyard, nobody calls the EPA. But Dr. Brennan introduces that term we mentioned earlier, irreparable breakage.
Break that down for us, because this is the absolute crux of the argument.
So, irreparable breakage is the idea that the asteroid itself has inherent physical integrity. To mine it, to extract the iron or the water or the platinum, you have to destroy it. You are fundamentally altering its mass, its orbit, its physical structure. You are turning a mountain into gravel. Once you process an asteroid, it is gone. You can never, ever put it back together.
It's the Humpty Dumpty rule of astrophysics.
Exactly. And the argument Dr. Brennan makes is that even without biology, these bodies have 3 distinct types of non-monetary value that we're destroying. We are trading these values for cash, and once the trade is made, we can't reverse it.
Let's walk through those 3 pillars, because this really changes how you look at the night sky.
The first is scientific value. Think of an asteroid not as a rock, but as a library. These rocks are 4.5 billion years old. They are the leftovers, the crumbs from the formation of the solar system. They hold pristine isotopic data that tells us how Earth was formed, where our water came from, maybe even where the basic chemical ingredients for life came from.
So if you grind it up to make iPhone parts,
you've erased the library. You've burned the history books to keep the house warm. We might get some platinum out of it, but we lose the knowledge of our own origins forever.
That's a powerful image. What's the second pillar?
Cultural value. This one is a bit more abstract, but think about it. Certain celestial bodies hold a specific status in human heritage or imagination. We name them, we track them, they are part of the landscape of our system. If we just erase them from the sky, we are altering the environment that humanity has looked up at for millennia.
And the third pillar.
The third is the one that I think will resonate most with the tech-savvy crowd or the sci-fi fans. Future economic or habitat value.
This is the sci-fi angle, but the physics are completely real.
The physics are solid. There is a strong theoretical argument that near-Earth asteroids, NEAs, are the best real estate we will ever have. You don't live on an asteroid, you live in it.
Right, hollow it out.
Yes, you hollow it out, spin it up to create centripetal force that mimics gravity, and use the thick, rocky shell as a shield against cosmic radiation.
Because radiation is the big killer in space. If you build a tin can space station, you just get cooked. But if you have 10 meters of solid rock between you and the sun,
you are safe. So the argument is, if we pulverize these bodies now for immediate resource gratification, if we grind them into dust to get the metal out today, we are destroying the potential real estate of future human settlement tomorrow.
So by mining them for raw materials now, we might be destroying the only viable housing for our great-grandchildren.
Exactly. We are stripping the copper wiring out of the house before we've even moved in. It's a classic short-term gain for a long-term loss scenario.
And the biggest example of this risk, the crown jewel of the problem, is Psyche.
Oh, Psyche, the queen of the asteroid belt.
Tell us about Psyche. Why is this one rock so intensely important?
It's a beast. It's not just a rock. We believe it's the exposed core of a protoplanet that was destroyed billions of years ago. Imagine a planet like Mars, but strip away all the crust and the mantle, leaving just the raw iron-nickel core. That's Psyche. The scientific value is incalculable. It's a literal window into the center of a planet. We can't drill to the center of Earth, but we can fly to Psyche.
But under current laws.
Under current laws, Psyche is just a rock. There is absolutely no legal distinction between Psyche and some random piece of gravel tumbling past Mars. If Astroforge or Carmen Plus or anyone else had the propulsion to get there and the drills to cut it, they could legally turn that protoplanetary core into paperclips.
That is the first mover problem Dr. Brennan warns about. There's no mechanism to say, stop, this one is a national park.
Right. We have UNESCO World Heritage Sites on Earth. We protect the pyramids. We protect Antarctica. We even protect shipwrecks like the Titanic. But in space, it's first come, first served. If you can catch it, you can keep it.
I want to pivot to the other environmental fear, which is less about preserving the rock itself and more about protecting what's around it. The debris issue.
The kinetic hazard.
Right. The fear is that if these budget-constrained startups start blasting rocks apart, they create a cloud of shrapnel, a shotgun blast in space. And that debris could hit other probes or satellites or even other mining craft.
Now, this is a very valid concern in low Earth orbit, or LEO. That's where all our satellites are, and it's incredibly crowded. We worry about the Kessler syndrome there, a chain reaction of collisions that traps us on Earth. But here, regarding the asteroid belt, we actually need to push back a little bit on the paper, or at least add some crucial astrophysical context.
We have to do the math.
We have to do the math. Dr. Brennan raises the debris concern, and legally, she is right. We need liability rules for it. If I break a rock and it hits your spaceship, I should obviously pay for it. But astrophysically, the physical risk of that actually happening is incredibly low.
Because space is just big.
It is mind-bogglingly big. When you see asteroids in movies, like in The Empire Strikes Back, Han Solo is dodging rocks every 2 seconds. It's this chaotic field of flying stones. In reality, even in the densest part of the main asteroid belt, the average distance between objects is about 1 million kilometers.
1 million kilometers.
That is 2.5 times the distance from the Earth to the Moon. So you could explode an asteroid, turn it into 1 million pieces, and the chance of one of those pieces hitting another asteroid or another spacecraft is statistically negligible.
So the debris cloud just dissipates.
It just floats away into the void. It becomes literal dust in the wind. The spatial volume is so vast that dispersal happens almost immediately.
So the space debris argument for asteroids is a bit of a red herring.
It's not a zero risk, but compared to the legal risk of someone stealing a planet's core, it's minor. The vacuum of space is a very forgiving place for dust. The real problem isn't the dust, it's the lawyers.
It's always the lawyers. Let's get into that, the jurisdictional vacuum, because this is where the rubber really meets the road. If I am the CEO of a mining company today, what laws do I actually have to follow?
You are looking at a mishmash. That is the technical legal term. You have a stack of contradictory treaties that have no enforcement power and national laws that might not be recognized by anyone else.
Lay them out for us. Where does this whole legal framework start?
Okay, the grandfather of them all is the Outer Space Treaty of 1967, the OST. This was written during the absolute height of the Cold War.
So the vibe was basically, please don't put nukes on the moon.
Precisely. It was about preventing a supervillain base. It states clearly that no nation can claim sovereignty over a celestial body. The U.S. cannot plant a flag on Mars and say, this is now America. The Soviet Union couldn't claim the moon. It was entirely about keeping the peace between superpowers.
But it doesn't say anything about Elon Musk.
And that is the massive loophole. It is completely silent on private corporations. It says nations can't own space. It doesn't explicitly forbid a private company from extracting resources. It's an interpretive gray area wide enough to fly a starship through.
So they tried to fix this later, right?
Yeah.
Because they realized the gap.
They did. In 1979, they drafted the Moon Agreement. This is often called the Communist Manifesto of Space Law, mostly by its critics. It declared space resources the common heritage of mankind.
That sounds lovely on paper. What does it actually mean in practice?
It basically said, if you mine it, you have to share the benefits with everyone. You can't just keep the gold. You have to distribute the wealth to all nations, specifically developing nations. It called for a strict international regime to govern any exploitation.
Let me guess. The U.S. and Russia didn't love that idea.
They hated it. The major spacefaring nations absolutely refused to sign it. They argued it would instantly kill the incentive for commercial investment. Why would I spend billions of dollars and risk bankruptcy to go to an asteroid if I have to give the profit away to a country that didn't invest anything? So in international law, if the big players don't sign a treaty, it's basically just a nice piece of paper. It holds no customary weight.
So we have a Cold War relic that's way too vague and a socialist utopia treaty that nobody actually signed.
Exactly. And into that void steps the United States Congress with the Space Act of 2015. This was a total mic drop. The U.S. unilaterally passed a federal law saying if an American citizen or an American company recovers a resource from an asteroid, they own it. Period.
That feels incredibly aggressive. That feels like finding a loophole in the Outer Space Treaty and just ripping it wide open.
It is aggressive. It stands in direct tension with the spirit of those international treaties. And what it effectively created is a flag of convenience system for space.
Like with shipping.
Exactly like shipping. You know how cruise ships register in Panama or Liberia to avoid strict taxes and labor laws? Now, space mining companies incorporate in the U.S. or Luxembourg because Luxembourg passed a similar law just to get legal protection for their mining activities.
But this creates a massive liability gap globally.
It is the ultimate lawyer's nightmare. Imagine the scenario. An American company, Astroforge, lands on an asteroid. A Chinese company arrives 3 days later and says, actually, we claim this. The American company says, according to the U.S. Space Act, it's ours. The Chinese company says, we didn't sign the U.S. Space Act. We don't recognize your domestic law. Who do you call?
There's no space police.
There is no court. There is no arbiter. If that dispute turns kinetic, if someone pushes someone else's rover or cuts a fuel line, there is no framework to resolve it other than brute force or diplomatic shouting matches back on Earth.
This is exactly why Dr. Brennan is screaming for a new paradigm. We need a referee.
Right. And the model she proposes in the Acta Astronautica paper is really interesting. She points to the ocean. Specifically, she points to the International Seabed Authority, or ISO.
The ISA manages the deep ocean floor, right? The stuff outside any specific country's borders.
Correct. The global commons. The logic is parallel. The deep ocean belongs to no one, just like space. So the ISA was created to issue permits, monitor pollution, and ensure that deep-sea mining doesn't destroy the ocean ecosystem. Dr. Brennan says, copy-paste this for space. Create a World Space Authority.
What would that realistically look like?
She outlines 3 main pillars. First, an independent international monitoring mechanism, essentially space inspectors. Second, mandatory environmental impact assessments, or EIAs, before you're even allowed to launch. And third, an adjudicatory body for dispute resolution, a space court.
It sounds totally logical on paper, standardize the rules. But, and this is a massive but, we have to look at how the ISC is actually doing down here on Earth, because my understanding is that deep-sea mining regulation is a bit of a mess right now.
Spoiler alert, it is not going great. The ISA has struggled significantly. And we have a very specific example of this failure that Dr. Brennan highlights in her analysis. The Nauru incident of 2021.
Nauru is a tiny island nation in the Pacific. How did they break the system?
They utilized a legal loophole called the 2-year rule. They basically sent a formal letter to the ISA saying, we are ready to mine. We have a corporate partner ready to go. You have exactly 2 years to finalize the comprehensive rule book. If you don't, we're going to start mining under whatever provisional, incomplete rules exist right now.
They held a gun to the head of the UN regulators.
They absolutely did. The intent was to force the slow bureaucracy to move faster.
And did it work?
No. The deadline passed. The international community still couldn't agree on the draft exploitation regulations. There was just too much infighting, too many conflicting interests between environmentalists, mining companies, and nation-states.
So if we can't even agree on how to mine manganese nodules on our own planet in the ocean, which is relatively accessible,
what chance do we really have of agreeing on a framework for the asteroid belt? That is the sobering reality check of this entire paper. The ISA model is fragile. It is inherently reactive. It gets paralyzed by politics. Dr. Brennan's proposal is arguably the most ethical solution, but the Nauru precedent suggests it might be a practical failure.
It feels like we are watching a slow-motion car crash between two totally different eras. We have 21st century technology, lasers, AI, ion drives, and we are trying to govern it with mid-20th century bureaucracy.
That's the defining characteristic of this era. The engineering is succeeding and the diplomacy is failing. We have companies like Asteroids that can calculate an intercept trajectory and land on a dime in deep space, but we have diplomats who can't agree on a single paragraph of text in 2 years.
So where does this leave us? If the treaties are broken and the ISA model is gridlocked, what happens next month, next year?
We enter the phase of technological determinism.
Which means what, exactly?
It means the technology decides the rules, not the other way around. Dr. Brennan discusses the concept of forced legal evolution. History teaches us that laws for new frontiers, like the Wild West or even the early internet, usually aren't written in advance. They are written after the disaster.
We didn't have seatbelt laws until people started flying through windshields. We didn't have the Titanic safety regulations, lifeboat rules, until the ship actually sank.
Exactly. The prediction here is that we are heading for a Wild West scenario, a gold rush where the mechanics of extraction precede the establishment of order. The companies like Astroforge and Carmen Plus are going to go. They are going to mine. They are going to create facts on the ground or facts in the void. And eventually, inevitably, something will happen.
A collision. A massive claim dispute over a platinum deposit.
Or maybe they destroy a scientifically priceless body like Psyche, and then only in the aftermath of that irreversible loss, the international community will finally wake up, convene, and write the laws.
It's a completely reactive system. We are essentially waiting for the catastrophe to prompt the legislation.
It's a dangerous way to run a solar system. The final synthesis of all this material is pretty stark. Without immediate intervention, the preservation of our cosmic heritage, the scientific data, the cultural value is currently left entirely to the discretion of profit-driven entities.
We are trusting the fox to guard the henhouse, simply because the fox is the only one who bought a spaceship.
That's it. That is the perfect summary. The divergence between the engineering success of missions like Vestry and the absolute failure of diplomatic instruments ensures that the immediate future of the solar system will be determined not by treaties, but by capability. If you can do it, you will do it.
It really puts the Vestry mission in a new light for me. It's not just a cool tech demo anymore. It's a stress test of whether we can be responsible stewards of a completely new environment.
And right now, the jury is out. We are venturing into a new environment with very old habits. The technology has evolved, but our governance remains strictly terrestrial.
So here's the thought I want to leave you with today. We often think of space as out there, separate from us. But the materials in those asteroids, the iron, the water, the carbon, that's the exact same stuff we are made of. When we talk about irreparable breakage, we aren't just talking about breaking a rock. We are talking about breaking the history of where we came from. If we burn the library of the solar system just to fuel the economy of the 21st century, what will the 22nd century think of us?
Are we explorers, or are we just locusts with better rockets?
That is the question. Thanks for joining us for this analysis. Keep looking up and maybe keep an eye on what they're doing with those lasers.
See you on the next one.